Welcome to part 5 of the 6-part series. Here we'll cover cascading. Complete combustion setup on all boilers before cascading the boiler bank. Here I'm showing an example of a terminal strip. And terminal strips may be a little different as far as the numbering, example OmniTherm versus MagnaTherm. However, for the example, I took an image and I put it in the presentation. So anytime you cascade, you have to have a system sensor. So in this example, our system sensor gets wired to terminal 35 and 36. Also, you'll cascade your wiring. In example, the lead boiler or boiler 1 here at 59, 60, and 61 will wire up to 59, 60, and 61 of all your member boilers. Now, you should also be using 3-wire shielded cable. Again, that's 3-wire plus the ground, okay? Not 2-wire in a ground, but 3-wire in a ground. Anytime you land the system sensor on that lead boiler, on the home screen, you will see the system sensor icon. And here in this example, we're showing 102-degree temperature to that system sensor. So from the home screen, press configuration. And here, choose your cascade option. So click on cascade icon, and this menu will come up with 3 more options. And we'll start with settings. Choose your settings icon. And here I'm showing an example of the Pennant Addressing. Now, Pennant is the first product we released Laars Linc on. And the range for cascading here is -1 or -1 to 7. So we can cascade up to 8 boilers. They're going to be defaulted for a -1. That means they're not set up in cascade. So here on Pennant only, you're going to address the lead boiler as 0. Your member boilers, you'll go into all your member boilers, choose address, back out your number, and type in example 1 would be your next boiler in line. So again, on the Pennant only, your lead boiler becomes addressed as 0. On all of the other products, OmniTherm, MagnaTherm products, etc., the address range is 0 to 8. And they're going to be defaulted for 0. That means they're not set up as a cascade bank, and you'll have to address them. So here on all of the other products, your lead boiler becomes address 1. So you're going to use your back arrow, back out 0, type in 1, enter, and our lead boiler is 1. You'll also go into your member boilers. Don't forget to log in with the password for the installer level. Address should be highlighted already for you. And example, boiler 2 becomes boiler 2. Boiler 3 becomes 3, etc. So you'll address those. Now, you can just look at that address range. So again, all of the other products are going to be ranging from 0 to 8. Leader becomes 1. The Pennant only, that range is from -1 to 7. Now, the next thing we'll talk about is base and drop load. So here you're going to choose your base and drop load, and this menu will come up. And I'm going to go through an explanation of how it works. So again, base load, drop load. And here I'm going to show an image from one of our I&O manuals, installation operation manuals. And the image we have here from the manual is for a high turn down. It's a 20-to-1 product, meaning it's going to modulate all the way down to 5% of fire. So in this example, follow the recommended base load values. And you can change these. Example, if you didn't want 75% for a base load, you could choose 80 or 70. How does it work? Well, here I'm showing 2 boilers, or an image of 2 boilers. So one of the boilers is going to come on a demand, and let's say that's boiler 1. Whichever one is in rotation next will come on and operate. And let's say that boiler lights off at 25% of fire. It has to modulate up. Let's say we have a set point of 160. So it will start to modulate up. And when it gets to the base load value, which in this example is 75%, we'll now bring on boiler 2. However, we're running at 75%. So boiler 1 is going to drop back to half of that value. So in this example, 75% divided by 2 means boiler 1 is going to drop back to 37.5%, waiting for boiler 2 to come on. The reality is we don't go by half increments. So when boiler 1 modulates back, it'll be 37%. It waits for boiler 2 to come on. Again, boiler 2, let's say, fires at 25%. It's going to stay there for a couple of seconds for smooth light off, and that will then modulate to 37%. Once they're both at that 37%, they can modulate together. In this example, maybe they go up to 100%. Maybe it's only 80%. Maybe it's 60%. So they'll modulate together in parallel. Now, as we're approaching a target temperature, I use the example of 160, your boilers will start to modulate back. And as we get closer to 160, we're now at that drop load. And here we're showing the recommended drop load of 15% of modulation. So here we are down to 15%. We're going to drop off boiler 2. However, 2 boilers running at 15% is 30%. So boiler 2 will drop out, but boiler 1 will go to 30%. And it will operate there for the last couple of degrees. Hypothetically, 2 more zones open out in the system, and that boiler has to modulate up. It can. If it gets back to that base load, the example we're showing is 75%, it would bring boiler 2 back on. However, for our example, let's say it's now right close to target temperature, it's going to start modulating back to its lowest percentage of fire. I'm using an example of a high turn down boiler, a 20-to-1 in modulation, 5% is its lowest percentage of fire. When it reaches that, it will shut off. My next example will be 3 boilers. So boiler 1 comes on in this example at 25%, modulates to its base load. Again, we're going to divide that by 2, let boiler 2 come on. They're both together in this example, 37%. They're going to modulate to the base load. And if we have to bring on boiler 3 at the base load level, boiler 3 will come on. However, what are we operating at? In this example, we're operating at 150%. We're going to divide that by 3 boilers. So boiler 1 and 2 will modulate down to 50%. Wait for boiler 3 to come on. In my example is 25% of fire. Now that modulates to 50%. Once they're all there, they can modulate to wherever they need to. Maybe it's 75%, maybe it's 80%, maybe it's 100%. Now they start modulating back. Once they're back, all 3 boilers are at that drop load value. Boiler 3 will shut off, but we're running at 45%. So we're going to divide by 2. So boiler 3 shuts off. Boilers 1 and 2 in this example will operate at 22%. And now they'll modulate down, or maybe up for a couple percentages, but when they modulate back to that drop load, boiler 2 will shut off, and boiler 1 will operate at that 30% of operation. When that modulates back down to its minimum percentage of fire, 5%, it will shut off. And I'll show one more example. Here we got 4 boilers. So boiler 1 comes on, modulates to 75%. That value gets cut in half. Boiler 2 comes on. Now they'll both modulate up to the base load. Now, once you're at base load for boiler 1 and 2, again, that value gets cut in half. Boiler 1, 2, and 3 will fire. And if we come up to base load for all 3 boilers, we can now fire boiler 4. Keep in mind, we have to look at the percentage currently of 3 boilers running. And in this example, 75% times 3 boilers, call that 225%. You're going to divide that by 4, and that is 56%. So boilers 1, 2, and 3 will modulate back to 56%, wait for boiler 4 to fire, modulate up to 56%. Once they're all there, they can modulate together in their range of wherever they need to be. As they come down to the drop load, now we can drop off boiler 4. But if we've got 4 boilers running at 15%, that is 60%. Drop off boiler 4, boilers 1, 2, and 3 will operate at 20% of fire. As they modulate back to the drop load, boiler 3 will shut off, and boiler 1 and 2 will operate at 22% of fire. Now, as they modulate back down to the 15%, again, boiler 1 will operate at 30% of fire, modulate down to its 5%, and shut off. And 4 to 8 boilers are going to follow the same operation, the same manner. So just go through your modulation, understand that they'll get cut in half when you're bringing on another boiler or increasing as you're on your drop load. Back to the cascade parameters. Here I'm showing lost lead backup set point. And I'll show you the 3 options for lost lead boiler. But one of the options are you can go in and choose a value that if the lead boiler gets powered off, the member boilers will operate on their own set point. So in this example, we've backed out the number and typed in 180. So if I'm looking for 180 degrees out in a loop, that leader gets powered off, the member boilers will operate on whatever set point you gave them. Now, this will have to be set up in all boilers, not only the leader, but if I've got 2 other boilers, I have to go into boiler 2 and boiler 3 and set up the lost lead backup as well. All right, so next I'm going to jump past rotation for a minute and go to redundant and explain that lost lead backup. So here, under the loss of the lead setup is how it's listed. You have 3 options. It's defaulted for disable redundancy. And what that means here in the bottom of the image, I'm showing 4 boilers. If someone was to power off the leader, nothing is telling the member boilers to fire. So the whole bank of boilers is down. So one of your options is you can come in and choose redundant lead. So that means we could have 2 leaders. So we could set up boiler 1 as a leader and boiler 2 as a leader. And now if someone powered off boiler 1, boiler 2 would be the leader for the other boilers in the bank. And you would have to get in and set up boiler 2 for set points, outdoor reset, etc. Now, also, boiler 2 will need a sensor out in the system. Why? Because your first sensor is wired to boiler 1. So I'll get in and explain a simple option for that. So anytime a boiler, in this example, boiler 2 is going to be set up as also a backup leader or redundant leader, it does need a system sensor. Any cascaded bank, you have to have system sensors. So we do supply with every boiler a tank sensor, and that tank sensor would go in a well. So what they could use is the tank sensor out in the system, and there are 4 wires. It's almost 2 resistors in the sensor well. And here's an example of the brown and white wire. There's a little rubber band. So that could maybe go to the lead boiler, and your second leader could have the green and yellow wires wired into them for the system sensor. Our next option here is boiler internal set point. So here we have 1 leader and 3 other boilers. So by going into that boiler internal set point, which I showed you an example of 180 degrees, now if someone was to power off that lead boiler, the member boilers would all come on and operate to that internal set point you gave them. So that'll protect the building from freezing. Next, we'll come in and we'll talk about rotation. So choose the rotation icon, and here I'm showing 3 boilers. Now, you're going to do this on the lead boiler for rotation setup, and you have to have addressed that lead boiler as a leader. And when you do, rotation setup becomes available. If you did not set up lead boiler, this will not be available to you. So once the lead boiler is set up, you can come in and click rotation setup. Now how it works is whichever one's in rotation right now, in this example, boiler 1 is, maybe tomorrow morning, boiler 2 is the leader in rotation. The next day, boiler 3 becomes the leader in rotation. So that's your rotation. And you have a couple of options. It's defaulted for runtime. So under runtime, you can get in and choose runtime hours. Example, 24 hours. So every 24 hours, that boiler will rotate, or maybe every 12 hours, maybe every 48 hours, whatever you want for rotation, you could type that value in. Your other option is reoccurrence. choose reoccurrence, and now you can choose the time of day. So in this example, time of day, hours, I've highlighted hours, I've typed in 7, then type in minutes, 00 or 30, and now every morning at 7 a.m. or 7:30, those boilers would rotate. And you could choose how many days. So I want them to rotate in that example every morning at 7:30 a.m., or maybe it's every 2 days at 7:30 a.m., or once a week. So you can take it all the way up to 365 days a year. Please don't forget to go in and watch part 6 of the 6-part series.
Thank you.